right, welcome back. Our second flipped classroom lesson of the year is about scientific notation. So this is really a little bit more of a math lesson than a science lesson, but this is incredibly useful and necessary for our understanding in chemistry. So first, let's talk about what scientific notation is. It is a way of expressing numbers. You've probably learned it, I think maybe in Algebra 1. So why do we use scientific notation? Well, in science, we deal with some really, really large numbers. As an example, when we talk about the unit a mole is 602200000, and I'm not going to give you all those zeros, particles. It is a lot of particles. That is a huge number. But we also deal with some really, really small numbers. So if we were to think about the mass of an electron, it's tiny. That is a tiny, tiny, tiny fraction. Okay, so we have some really big numbers and we have some really small numbers. So there are a couple of difficulties in dealing with numbers that large and that small. One is that it's really easy in writing them down or putting them into a calculator to miss a zero. And then you're going to be off by a factor of 10, and that's a huge amount. The other reason is that it's really difficult simply to make calculations with them. So if we were trying to figure out the mass of 1 mole of electrons, we would be multiplying this really, really tiny number with all those zeros by a really, really huge number with all those zeros. And I don't know about you, but my calculator simply won't allow me to put in all of those zeros. And my brain certainly can't handle them. So in order to simplify our lives, in order to make these kinds of calculations easier, we have this tool called scientific notation. And so scientific notation is just a way of representing very large or very small numbers. And we use this form where we have a number between 1 and 10. And that number we call the coefficient. So our coefficient is between 1 and 10 times 10 to a power. And that power is always going to be an integer. So this is standard scientific notation. In order for it to be in standard scientific notation, it's really important to remember to have that coefficient be between 1 and 10. So for us to practice this, we're going to look at this number. It is 2,500,000,000. So that's a really large number. So how do we convert this really large number in standard notation into standard scientific notation? So the first thing we're going to do is insert an understood decimal point. So we all know that at the end of this number, there's a decimal point. There's 0 after that. We don't really care about that 0 right now. So we want to move that decimal so that only 1 digit is to its left, so that we get that first number, that coefficient, to be between 1 and 10. So if I put the decimal point right here, that's going to give me just a 2 to the left of the decimal point. So now I'm going to count how many places I have to move the decimal point. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to rewrite this number now in the form m times 10 to the n, where n is the number of places I moved the decimal point, and m is the number, the 2.5. So now I have 2.5 times 10 to the 9. The exponent is the number of places we moved the decimal, and the 2.5 is the number after we drop all the zeros. We only drop zeros, and we'll talk about that when we talk about significant figures. All right, so let's practice with a really small number. So this time we don't have to insert an understood decimal point. The decimal point is there. And we're going to look and figure out where we need to move it so that there will be 1 number to the left of the decimal. So this time we're going to put the decimal point between the 5 and the 7. Notice that when we do that, that's going to give us 1 number to the left. We don't care how many numbers are to the right of the decimal point. we care that there's only one number to its left. So we're going to count how many places we're going to move the decimal point. 1, 2, 3, 4, 5. So now we're going to rewrite again in the form m times 10 to the nth. This time, however, because we have a small number, because we're moving the decimal place to the right, we're going to have a negative exponent. So now we have 5.79 times 10 to the negative fifth. The exponent is negative because the number we started with was less than 1. So remember, if we move the decimal place to the right, the exponent is negative because we started with a number smaller than 1. If we move the decimal place to the left, the exponent is positive. Okay, so I'm going to ask you guys to think about a couple of numbers here. So we have this number 5.79 times 10 to the negative fifth. If we had a number 6.4 times 10 to the negative seventh, which number would be larger? So 6.4 times 10 to the negative seventh or 5.79 times 10 to the negative fifth? Well, 6.4 is bigger than 5.79, but a 10 to the negative seventh means that its decimal place is farther to the left. And so we know that 6.4 times 10 to the negative seventh is actually a smaller number. By the same token, which number would be larger? 4.4 times 10 to the fifth or 2.5 times 10 to the ninth? So 4.4 times 10 to the fifth, although the 4.4, that coefficient is bigger than 2.5, the exponent is much smaller. And so that's going to be a smaller number. So when we're comparing numbers in scientific notation, it's really important to pay attention to the exponent. Okay, so let's talk about how we perform calculations in scientific notation. We're actually going to start with the easy ones. Okay, we're going to start with multiplication and division. So when we multiply and divide in scientific notation, you simply, for multiplication, we just multiply the numbers in the front and we add the exponent. So in this example, we have 4 times 10 to the sixth times 3 times 10 to the sixth. So we're going to multiply the numbers in the front. It's going to give us 12. And then we're going to add the exponents. That's going to give us 10 to the 12th. Now, that is a valid number, but it is not standard scientific notation. So in order to get this into standard scientific notation, we're going to move the decimal place 1 to the left. When we move the decimal place to the left, we're going to increase that exponent by 1. If we move the decimal place to the right, we're going to decrease the exponent by 1. If we are dividing, we're simply going to divide the first numbers and subtract the exponents. So 4 times 10 to the sixth divided by 3 times 10 to the eighth. We're going to have 1.33 because that's 4 divided by 3. But now we're going to subtract the exponents. So 6 minus 8 is negative 2. So we're going to have 1.33 times 10 to the negative second. So pretty simple and straightforward. I'm going to let you guys try this problem. 1.62 times 10 to the negative sixth times 7.18 times 10 to the negative second. So I'm going to ask you to pause the video here and work out this problem. You can use a calculator, but I want you to use the calculator separately. I want you to multiply the first two numbers and then add the exponents. So when we do that, and you've come back from the pause, we're going to get 11.6 times 10 to the negative sixth, and we're going to change that to standard notation. We're going to move the decimal place to the left, which means we're going to increase the exponent by 1 and have 1.16 times 10 to the negative fifth. So why am I asking you to do this? Because you are always going to be allowed to have a calculator in chemistry class. Well, I want you guys to have an idea of the approximate answer before you put the numbers into your calculator. So Why do I want that? Because if you slip, you have to, in your modern calculators, you have to enter the division problems with your numbers in parentheses. If you don't, you'll get the wrong answer. If you've estimated the answer, then you'll notice. So I want you guys to have this skill so that you'll catch when you make a mistake. Okay, let's go back to the one that's a little bit more challenging, and let's talk about addition and subtraction. So when we're adding, if the exponents are the same as they are in this example, we're simply going to add or subtract the numbers in front and bring the exponent down unchanged. So we'll have 7 times 10 to the 6th. Okay, so that's pretty simple. Same thing for subtraction. If the exponents are the same, we're just going to do the subtraction problem and bring down the exponent unchanged. So that's pretty simple and easy. It's a little more challenging when we have numbers whose exponents are not the same. If the exponents are not the same, we have to move a decimal to make them the same. So we always want to move the decimal on the smaller number. So remember, which one is the smaller number? The one with the smaller exponent. So 7 times 10 to the 5th is smaller than 4 times 10 to the 6th. So we're going to move the exponent on the 7 times 10 to the 5th. And that's going to give us 0.7 times 10 to the 6th. That's not standard scientific notation, but while we're in the middle of a calculation, that's okay. Now we can simply add the numbers and bring down the exponent, and we have 4.7 times 10 to the 6th. Same thing for subtraction. Okay, one more time. I'm going to give you guys a problem. This time I'd like you to do it without using a calculator. Okay, so here's your problem. 2.37 times 10 to the negative 6th plus 3.48 times 10 to the negative 4th. So you have to look and figure out which one is the smaller number and move the decimal on the smaller number. So I'm going to ask you guys to pause me here and work through this problem, and then I'll step through the answers with you. So I'm going to insert my zeros in front. I'm going to move the decimal 2 places to the left, 1, 2, and that's going to give me 0.0237 times 10 to the negative 4. And I'm going to add those numbers up, and I'm going to get 3.5037 times 10 to the negative 4th. And we'll talk about rounding when we talk about significant figures. All right, that does it for us for today. As always, make sure you write down your questions and let me know at the beginning of class. See you soon.